Hey everybody, and welcome back. This will be our fourth lesson of linear relations, and this is going to be the continuation of our last lesson, which was graphing ordered pairs. So today what we're going to be looking at is kind of combining all the steps and concepts that we've learned so far and putting it all together. So we'll be looking at the equations, manipulating the equations, writing ordered pairs, taking ordered pairs and plotting them, and also creating our linear relation. So our line, which is going to be graphed on the graph below. So without wasting any other time, we'll jump right into it. So the equation that we're going to be looking at here is y equals 5x subtract 2. So just like we were doing in all of the previous lessons, I'm just going to go down by 1 here. So writing out our equation that we're using, we have y equals 5x subtract 2. Now remember, we're going to be inputting our values for x. So y equals 5, then in brackets, negative 2, subtract 2. Y equals 5 multiplied by negative 2, which gives you negative 10, subtract 2. Y equals negative 10 subtract 2, negative 12. So when we use negative 2 for a value of x, it resulted in y being negative 12. So remember, when we're writing our ordered pairs, x is going to be your first one listed, and y is going to be your second one listed. So let's look at two more examples here. Now we're going to be using x as negative 1. So same equation that comes across. Y equals 5 multiplied by negative 1, subtract 2. Y equals negative 5, subtract 2. Y equals negative 7. So move over. When we had x as negative 1, y was negative 7. X is written first, y is written second. Now we're going to use x as 0. Same equation. Y equals 5 multiplied by 0, subtract 2. Y equals 0, subtract 2. And that ends up with y equaling negative 2. Back over to your table. When we used x as 0, y was negative 2. So x first, y second. Now, what do we notice here? Well, our change here is increasing by 1 every time because we chose that. What do we notice here? Well, we went from negative 12 to negative 7, so we had an increase of plus 5. Was that the same here? Yes, it was. So we increased by 5 every time, so that means the values below are going to follow the same pattern. From negative 2 plus 5 brings you to plus 3. 3 plus 5 takes you to 8, and 8 plus 5 takes you to 13. Now to write out our ordered pairs, x goes first, y goes second. X goes first, y goes second, and 3 and 13. So now we've finished off our ordered pairs, and what we're going to have to do is plot our ordered pairs. Now, looking at our graph here, you'll notice that it goes up to 10 in either direction. So anything over 10 is not going to fit. So negative 12 won't fit on there, and 13 won't fit on there as well. So what we're going to start off with is something that we know will fit on there. So we can start with this one here, or better yet, start with this one here, 0 and -2. So when x is 0, so we start off looking at our origin, which is right here in the middle, 0, 0. If we start off there, x is 0 and y is -2. Another one that'll fit on there is when x is 1. So when we're looking at x of 1, we have a y. When we have x of 2, we have a y of 8. When we have x of 3, though, we have y of 13. That won't fit. But when we have an x of -1, so looking at -1, we have a y of -7. So we got to move down to -7, and our point would go right there. So you can start seeing that it's creating a linear relationship, because if we connect these dots, which is the next thing we're going to do, it's going to create a line. Now, I'm going to get you to pause the video, and you're going to find any straight edge that you have. The best is a ruler, but if you don't have a ruler, you can use any flat edge that'll allow you to draw a straight line. Even if you have to use the side of your phone or the side of a book, anything will do for this just to draw a straight line. So I'll get you to pause the video right now and create your straight line. Now this is what your line should look like after you put it down, and I want to draw your attention to a couple important things. So it's important that you have these arrows on either side, because this means that the linear relation is always going to continue on in either direction. So there's going to be no stop to either side of this. Now it's important because it's not stopping, it has to always follow the pattern of x changing by 1 and y changing by 5. X changes by 1, y changes by 5. So it's always going to follow that pattern. So the above graph gave a straight line. Now, this straight line is showing that it is a linear relation. So a linear relation is one where the relation is a straight line. In a linear relation, a constant change is one quantity produces a constant change in a related quantity. So what that's meaning is as the x change, the y changes at the same rate every single time. So it's always consistent. Sliding over to our next table on the next page. Now this table is here just to reiterate the point that we talked about. So the values that we had were -2 and -12, -1 and -7, 0 and -2, 1 and 3, 2 and 8. So the changes that we had here were from here to here was +1, and here to here was +5. So our change in x every time was +1, and our change in y every time was +5 when we were moving down the table of values. So in the relation above, the constant change of 1 in the value of x produces a constant change of 5 in the value of y. In the next example here, we have y equals negative 3x plus 1. So moving over to the left or right here, we have y equals negative 3x plus 1, y equals negative 3. Now we have to come up with a value for x. So looking at our table here, well, we can fit from negative 2 to 2. So negative 2, negative 1, 0, non-negative 1, and 2. So our value for x is going to be negative 2 plus 1. So y equals, now we have a negative 3 multiplied by a negative 2. Now that results in a positive 6 plus 1. So y equals 6 plus 1, which is 7. So when we used x as negative 2, y was 7. Moving over to ordered pairs, negative 2 was our x, 7 was our y. Next one, we're going to have negative 1 as our value for x. Same equation, y equals negative 3 multiplied by negative 1 plus 1. Y equals negative times a negative is a positive, so positive 3 plus 1. Y equals 4. Back over to our table of values, negative 1 got us a y value of 4. So y equals negative 1 and 4. So what was our change here? Well, we set this one up as plus 1. This was a change of negative 3. So it went down by 3 here. Let's see if this happens again. Same equation. Y equals negative 3 multiplied by 0 plus 1. Y equals, well, negative 3 times 0 is 0 plus 1. Y equals 1. Back over to our table. When x was 0, y was 1. So what was our change here? From 4 to 1 is negative 3. So it is consistent. So we know that this is going to be a linear relation. So 0 and 1. Well, 1 subtract 3 is going to get me a value of negative 2. And negative 2 subtract 3 will get me a value of negative 5. So 1, negative 2, 2, and negative 5. That'll fill in our table here. So what I want you to do now is fill this graph in on your own, and I want you to look back at the notes that I posted to double check that you've graphed it correctly. So I'll give you time to do that now, pause the video, and then go over and check that you end up with the same graph as I do. After you've checked that your answer is correct, we're going to move on to example with 4x plus 2y equals negative 6. Now, we are going to manipulate this equation and isolate y by itself, but just as a reminder, you can actually solve this without manipulating it, but it is a couple more steps. So we'll show you both ways, just so whatever way works best for you is what you'll do. Now, for values for x, we're going to pick them again. So negative 2, negative 1, 0, not negative 1, and 2. So to solve it without manipulating the equation first, it's going to look like this. 4x plus 2y equals negative 6. Now we are choosing the values for x here. So 4 multiplied by negative 2 plus 2y equals negative 6. 4 multiplied by negative 2 is negative 8 plus 2y equals negative 6. Now we want to get y by itself here. So add 8 because we're doing the opposite. Now that'll cancel that off, and we'll be at 2y equals negative 6 plus 8. 2y equals negative 6 plus 8 gives us 2. Now to get y by itself, divide by 2, cancels, have to do it to the other side, divide by 2. So y equals 1. So we were able to solve this without manipulating the equation. So when we used x as negative 2, y was 1. So for ordered pairs, x is written first, y is written second. Now what we're going to do is we're going to look at manipulating the equation and isolating y by itself. Just to give ourselves some more room. For x plus 2y equals negative 6. Well, we want to get y by itself, so we have to move x to the other side. So subtract 4x, subtract 4x. That gives us 2y equals negative 6, subtract 4x. Now we want to get this 2 off of the y. So divide by 2, cancels, divide by 2, divide by 2, because everything has to be divided by 2. Y equals negative 3, because negative 6 divided by 2 gives you negative 3. Subtract 2x. So this will be our manipulated equation where we have y isolated. Now to use this, it makes our life a little bit easier. So this is my recommended way of doing it, but if you choose to solve it the other way, you can as well. So our equation that we're going to use is y equals negative 3 subtract 2x. Now we chose our values for x already, and we've already done negative 2. So we'll have negative 1 for our x value here. Y equals negative 3. Now we have negative 2 multiplied by negative 1, which gives us a positive. So a positive here, please pay attention to that one. And it'll be a positive 2. Y equals negative 3 plus 2 gives us a 1. So it was a lot less steps than doing it without manipulating the equation, but you can do it both ways. So when x was negative 1, y was negative 1. Now we're going to do x as 0 here. Oh, actually, we should do our ordered pair first. So negative 1, negative 1. Now we'll do x is 0. So same equation. Y equals negative 3, subtract 2 multiplied by 0. Y equals negative 3, subtract, well, 0, because you're multiplying by 0. Y equals negative 3. So when we used x as 0, it gave us a y of negative 3. And our ordered pair would be 0 and negative 3. Now let's look at this relationship that we have here. What's the common pattern? So we know that we chose this to be plus 1. Here to here, we went from 1 to negative 1. So we had a change of negative 2. So we subtracted 2. Same here, subtract 2. So we know this is going to be a linear relation because it's the constant change every time we change x by 1. So from -3 subtract 2, you end up with -5 and -7. Our ordered pairs would be 1 and -5 and 2 and -7. Using the ordered pairs that we've written down, we're going to start with plotting those points. So -2 for x value is the first one we used. So we find -2 on the x, and then we're going to move up to 1, which will bring us here. Our next ordered pair is -1, -1. So when x is -1, y is -1. When we have an x of 0 and y of -3, and we also have 1 and -5, so when x is 1, y is -5, and we can fit the next one on here as well. We have x of 2 and y of -7. So you can already start seeing that it's creating that linear relation. And now again, I'll get you to create that line connecting all the dots with the arrows at the end, showing that this is going to continue on in either direction, which should look like this for you. Now we're going to look at our last page for today. So this one here has a bunch of different steps that we're going to look at. So our equation is written at the top here with y equals 6 subtract 3x. Now it's asking us for part A to create a table of values for the relation for values of x of -3 to 3. Well, if you quickly look over, you're going to realize that that's not going to fit on our table. So let's change this to -2 and 2, because that will fit on our table. So -2, -1, 0, 1, and 2. Now we'll have to figure out our y. Part B says to graph the relation. Then part C is going to be what pattern are, it should be what pattern. Part C is going to be what patterns are in the graph. How do these patterns relate to the table of values? And then part D is going to be, is the relation linear? So are we getting that straight line? So our first thing though is we have to go back to part A and we have to look at our equation. So using this equation, we're going to answer for y. So y equals 6 subtract 3x. Now this is already nice because they've isolated y for us. So we can just put in our x values. So -3 multiplied by -2 is our first x value. Y equals 6. Now we have a negative times a negative, which will give you a positive 6. So don't forget about that positive. Negative times negative is always positive. So y equals 6 plus 6, which will give you 12. Slide over to our table. When x was -2, y was 12. Same equation, but we're going to change our x value. Our x value is going to be -1. Y equals 6. Now we have a negative times a negative again. Positive 3. Y equals 6 plus 3 equals 9. Write that down. Same equation. Y equals 6. Subtract 3 multiplied by 0. Y equals 6. Subtract 0. Y equals 6. So let's look at what our relationship is here. When x changed by +1, y changed by -3. Is it the same here? -3. So that means it's going to follow that pattern. So 6 subtract 3 is 3. 3 subtracts 3 is 0. Now part B says to graph the relation. Well, if we look at our table of values, if we use x as -2, y is going to be 12. Well, that isn't going to fit on this graph. So we're going to have to skip that one. And we'll go to x of -1. So you slide over to x of -1, and we're going to go up to y of 9. Get rid of that dot. Next, we have 0. So right when we're starting at that origin, so x is 0. And then we're moving up to a y of 6. When we have an x of 1, we're moving up to a y of 3. When we have an x of 2, we're moving up. Well, actually, we're not moving at all. We have our dot right on that spot, because when x is 2, y is 0. So you can already see that relationship happening. So I'm going to get you again to draw your line, connecting all the dots with the arrows at both sides. Once you have your line connecting the dots and the arrows on each side, you've finished off part B. And we're going to look at part C. So what patterns are in the graph, and how do these patterns relate to the table of values? Well, when we increased our value of x by 1, we decreased our value of y by 3. So, as the x value increases by 1, the y value decreases by 3. Now we can also see this pattern in the table of values that we looked at earlier. So when we increased our value of x by 1, we decreased our value of y by -3. Our next thing is the relation linear? So justify your answer. Now remember, our relationship is linear if it creates this straight line and it follows a continuous pattern. So is this going to be true? Do we create a straight line here? And is our pattern always increasing x by 1 and decreasing y by 3? Well, yes, it is, showing us that yes, we do create a straight line, and it is a constant change in x of +1 produces a constant change in y of -3. So this lesson today was a continuation, and it combined all of the concepts that we've looked at so far. So it's a good test to see if you're on track with your understanding and if you're making sense of all of the different ways we've manipulated equations, plotted points, looked at ordered pairs. So if there's any questions that you've got stuck on or any of the concepts that just aren't making sense, please feel free to email me as always and let me know your concerns. Other than that, have a great day.